This is a tutorial on how to do a water simulation in Blender. I'm running Blender 2.69. I need the screencast keys on here. Alright. So we're going to start with the basic cube. This is going to be the domain. So I hit 3 and 5 to get to the orthographic view on the side. And I want to scale this default cube up to so that it's 10 units long. So I'm going to go ahead and hit S for scale and 5 and enter. Now I've been told and read all over the web that it's critical that you consider scale when you're doing these. So something I want to show you here. I just scaled this up from 2, which is the default units, to 10. But if I go into the edit mode and display the side length, it's only 2. And I think that is a problem. So what you have to do is in object mode you hit Control A and accept the scale. And then when you go in and look, you can see the sides are now 10. So that's 10 units, whether it's meters or whatever it is, it'll be 10. So I think that's an important piece of the picture. Okay, so the things you have to have a domain for your simulation to happen in. You have to have some sort of fluid, whether it be a fluid object or an inflow. You have to, if you want particles, you have to have something to hold the particles, and you have to have some way to display the particles. That's the basics. You can have obstacles and such so that the water has something to hit against, flow around, that kind of thing. So I'm just going to set up a very basic one here. So this is my domain, and just to do it right, I'll call it domain. And I want it to display as a wire so I can see what I'm doing. Now I'm going to add an inflow. In this case, I'll put a cube in. I'll go to the front view and scale along the x-axis. Try that again. Along the x, that's a little too wide. Then I want to scale it down some altogether. Back to the side view, and we'll put it over here. So if each of these is a single unit, you can see that I'm placing this up about 1, 2, 3, 4, 5, 6, 7. So if it were in meters, it'd be 7 meters up. And then I'm going to designate this as an inflow. So we go to the Physics tab, Fluid, and do an inflow. And then I want it to come out rather than just drip straight down. I want to give it some force, so I'll set this to about there, and I'm going to let it come down a little bit so that it doesn't just squirt across to the side. Maybe a little more here, 2.2. And so this is the basics here, and then I want something for it to maybe flow around or whatever, so I'm just going to put in some, I'll just put in a cylinder, what the heck. And I'll set it down near the bottom. You want to be sure that it is inside of the domain. And we'll set that to an obstacle. And you can select what you want, free slip, partial slip, or no slip. I usually leave everything at partial slip. Seems to work fine. Free slip, just it doesn't try to adhere to the surface. So now we need something to actually contain the particles, or a particle holder is what I call it. So we put in a UV sphere. I'll scale it down a little bit. Scale's not important on this one. So this will be a fluid object, and it will be a particle system. Then we need something to actually display the particles. I like to use an icosphere and give it a texture to make it look like water. This can be inside or outside the domain, doesn't matter. I put it outside of the camera view. Anything I don't want to show up, you can also move it to another layer, whatever you want to do. It needs to be fairly small because it's going to be the actual water drops. Okay, so we have an inflow, we have an obstacle, and we have a particle holder. It's important that we have the particle holder and the domain pointing at the same directory. The domain is going to generate the particles, and the particle holder is going to read the data out of that same domain. So you got or same directory. So you got to have them pointing to the same place. Okay, so we've got that, and we want drops and floats. And I don't know that tracers are even necessary, but we'll put them in there. Now if you go to the particle tab, you can see the particles here. And we'll select object, and we'll put in the icosphere as the object to display. And I think I'll just leave everything at defaults. It works pretty good. Okay, so now we want to set up the domain. I like to do it last. And that's why it loses its shape once you set it up. It kind of goes into a glob. So to be able to tell everything's inside of the domain, I leave it till last. Okay, the display is pretty important. I usually set mine around 220. You know, whatever your computer can stand, the more of that, the better. You want your start time. If you want the simulation to start after the water is hitting the bottom, you could give it a 2-second start time. The important thing here is that you have 250 frames, 25 frames a second is 10 seconds. This simulation is going to run for 4 seconds worth of simulation spread across 10 seconds, so that means slow motion. So set it to 10. Wherever it starts is not important, unless you just depends on what you want, but always have a 10-second if you want it in real time. And you want to be sure that this directory is the same as that other one. And then fluid world, we want this to be 10 because that's as big as Blender allows, and we did set this domain to be 10. Fluid boundary, in order to use the particles you got to have at least 2. I like to put 3, and I've never tried removing the air bubble, so I don't know what that does. Tracers, I'll put 200 for a number, and 1.5 is a good starting place for particles. That generates quite a few. Excuse me. So once this is all set up, you probably want to save your work. And we'll just call it tutorial. And then you're ready to bake. The bake will take some time, so once it's finished baking, I'll come back and resume. We'll see what it looks like. Here goes. Okay, I'm back, and the bake is finished. Just as an FYI for you, time when you're doing your own. This particular bake with these settings at 220 resolution, 3 subdivisions, and 200 tracers, 1.5 on the generate particles. That generated 1004 files, and I started the project baking at 1:44 p.m. and it finished at 5:39 a.m. the following morning. So if you're doing this, you might want to set aside a little time for the baking process. Obviously, the lower your settings, the faster it'll bake, but the less realistic it'll look. So what I've done here right now is I've hidden the particles. I can turn them back on to show you. There's quite a few. I think in this case 1.5 is probably a little more than we actually needed. Got a little bit of a lag when I turn them on, so it takes a little while to share. So there's quite a few particles there, as you can see. And it looks like more than it will in the actual render, and I'm not sure why that is. So at this point, you know, we want to aim the camera and kind of just get ready to do some rendering. So I'm trying to turn that off, and it's a little bit sluggish. There we go. So now I should be able to get a little bit better response out of the. I just want to get this where we can see the. Oh, I didn't turn my screencast keys back on. Okay, so we'll slide this down a little bit. All right. So while we've got this, let's go ahead and just make a material for this. And I'll just use a plain old glass. And then we want to, for the drops that we're displaying, we want some glass as well. And then we'll go over here and do a render. And those drops should show up, so let's see what we get. It's a lot there, so it's going to take a little while to render. I think you'll find too that there's a lot of water in a box tutorials out there, and when you actually start doing something with the water besides just having it splash in a box, it gets a little more difficult. But getting the the basics of how to get the drops to work and the you know, the resolution, getting all that figured out ahead of time really helps. And I think that scaling issue where you scale something and it really doesn't change dimensions, I think that's pretty important. So I've noticed a little better outcome since I've figured that out, to scale it and then accept the scaling. It kind of resets it to the actual dimensions that it's supposed to be, and I think that makes a difference. So here comes the render. Looks a little gray because the whole environment is gray, but you can see it's going around the obstacle fine. We've got the splashes and the fine splashes and all of that. So I think at this point probably be good. We'll hide some of these from the render, and I think let's change the we'll use a sky texture just to give it some color. And I think on this here, on the drops themselves, just to make them show up a little more like spray, I'll go into the compositor area, and for this one we'll add a mix shader and do just a little bit of an emission. Let's see here. And I'll turn this strength down to like a 0.3, and this factor will be 0.1 maybe. And then let's go back over here and see what it looks like. If you're trying to get a project done quickly, so fluid simulation is not the place to do it. You just got to allow plenty of time for baking and plenty of time for rendering, because of the complexity and all of the transparencies and reflections. It was something like, what, 15 hours to bake this simulation, 250 frames worth. being a musician, when I'm doing something like this, I keep a Native American flute handy or a Udu drum, something like that. And when I'm waiting for these things to render, I usually will bang out some rhythms on the drum or play a few flute lines or something, write a song while I'm waiting for it to render. As an aside, one of the things I've found out about Blender is it takes over the sound system. I run a ASIO audio interface through a USB port hooked up to a mixing board, and when Blender's running, my DAW can't take control of the sound at all. It can't even use it. So it looks like I ran out of memory. Isn't that something? Yeah, I ran out of memory, so this one isn't going to work. So I think I know where the problem is. Let's go get rid of that. I guess I got, here we go. Let's get rid of this whole system here, because I think that's the culprit. Boy, it's bogging down a little bit, but we'll get there. Definitely a good idea to save your work once in a while. Now let's see if that thing will render. I suspect that mix shader had something to do with it. Most likely I would cut back on the number of drops. And I'm running an NVIDIA 650 Ti, GT 650 Ti. It's got 700 and some CUDA cores, 2 gigs of RAM. It's a pretty good card. But Blender has a way of overdoing that. Many times I get an error message from the card that says I can't do this, and it shuts Blender down. Just about time for the render to actually start now. Here it comes. So that's looking a little better with some color and lighting on it. Yeah, I'm not going to spend a lot of time going into materials and environment. Essentially when I'm doing a project, I build the fluid system. I get it the water flowing however I want it to flow. Most of the time I'll have a fluid object and a waterfall, and the fluid object is a river, and it's already there, so that when the water comes down, the waterfall hits it, it's already interacting and it's already flowing. And then once I get the entire fluid system baked, then I go back in and put the rocks and the riverbed and the land around the river and all. I put that in afterwards. I make sure the fluid sim's working first, because obviously it's the part that really takes the work and the time. So I'm going to go ahead and render this out as an animation, and it's probably going to take several hours. So I'll pause this again and we'll go from there. Alright, I stopped the render at 52. It was getting to be pretty lengthy, taking over a minute per frame. And it's only like 52 out of 250. It gets longer as it goes because of the number of particles. I've selected the particle emitter so it highlights the particle. You can see how many there are. There's 1,446,955 fluid particles for this frame. I'm running a quad core at about 3 gigahertz with 8 gigs of RAM. And an NVIDIA GTX 650 Ti, and it's putting it right to the max on what I've done here. So most likely, if I was working this project, I'd back the resolution off and rebake it, or not necessarily the resolution, more the number of generated particles, because I've got too many here. It's more than is even needed at all. So at any rate, rather than spend hours baking, I just stopped it at 52. It's enough to demonstrate what's going on with the render and the simulation. So system's running a little slow because of the number of particles, so bear with me. Alright, so get into the render tab, and I want to play the animation so you can see it. Here it comes. Okay. Alright, so if you remember, this was 7 units up, which would be like 7 meters if I had it set to, metric. So at any rate, water falls, I guess, from according to the web, at about 9.8 meters a second. And this is actually hitting the floor at about halfway through the simulation. Frame 52 makes it just a little over 2 seconds. So it's the scale and all of that has worked out pretty well. And you can see it's really splashing and looking pretty accurate. The drops are making the spray. There's just too many drops. And the blackness of the drops is because the lighting, the default light in this scene is a excuse me, it's a point light, and it's sitting back here somewhere, so it's really not doing much for the scene. So the lighting could be adjusted. What's really nice is that as the water falls on a waterfall, if you go out and look at real ones, you'll see that it starts getting a little foamy and spray about halfway down, or as it falls. And that's what's happening here with these particles. They're starting to spray out and show a spray about halfway down. So if you took the time to set up all your lighting and set up the materials better, I think you'd see some nice results. And so I guess just to recap, what you've got to have to get a fluid simulation working is you've got to have some sort of an emitter. And I think the two options are fluid, which is just a body of water that will react to gravity. And then there's inflow. You've also got outflow if you want this tank to not fill up. You put an outflow in there and it'll act like a drain. Then there's control systems and things like that. But this is just to get the thing running. So the particle system is, to me, it's essential in getting the water to look real and have the spray and the splatter that it needs to have. So you got to have something to bring the water into the scene. You got to have the domain to house the simulation. Any objects for obstacles, this could be a rock in a river, that kind of thing. Got to have something to generate the particles, an emitter, and then I use a particle object to display and give it some sort of a texture or material. Excuse me. So in this situation, if this were a real waterfall, then I'd go back, now that I've got the simulation running, I'd probably put a rock here instead of this, just take it out and make the rock of similar size, or have a rock there in the first place. Excuse me. And then, you could put in your rock wall, however you want the water to be coming over the whatever it is you want. You could have an industrial scene with some sort of a drain culvert or something like that, or whatever you're looking for. But once you've got the simulation working, you build your scene around it. If I were making a river, I would have put an obstacle down here to cause the water to be channeled away, and then that would form the river, and then I'd build my scenery around that afterwards. Make the domain longer, and then it would come clear off the scene, whatever you need. And also there's a myth that you can only have one domain in a given project file or a given scene, and that's not true. You can only have one when you're actually baking, but you can bake a scene and then you disable the domain and you make your second domain and put your water system together and bake that, and then you turn them both back on and they will play at the same time. You just cannot bake at the same time. I know because I've done many times, but that's the subject of another tutorial. But if you want another water system, all you got to do is just be sure you don't have two active ones at the same time when you're baking. So at any rate, I hope this has been helpful. It's it's just another water in a box tutorial, but you gotta figure out how to make it work before you start trying to put it in a project, or you just get nothing but headaches. So thanks for watching.